Let's talk about how to find the area of irregular figures. Our learning target for today is students will be able to apply formulas to the area of irregular figures. So we're going to use all of our area formulas to find the area of our irregular figures. Okay, make sure you write down your heading. I'm going to move on to the next slide if you need to pause. Okay, in our next slide we're going to talk about how to find the area of irregular figures. What you want to do is you want to decompose the irregular figures. Okay, decompose or decomposing means to separate a figure into smaller parts. So you want to take this complex shape and break it into the shapes that we already know. So you want to break it into triangles and parallelograms. So basically, for the most part, you're going to break them into triangles and rectangles as much as possible, and then you can find the area of each one of those. That's decomposing. So you're breaking it apart into smaller pieces. Okay, the picture on the right there at the windows, there's an example of an irregular figure you might have if you were painting that room. If you're painting that room, you'd have to figure out the area to know how much paint to buy. Well, you're not going to paint the windows, so you would find the area of the room, and then you'd have to know, oh, there's 3 rectangles in the middle. I need to subtract those from my wall. So there's a real-life example of a irregular figure finding the area, and just so you know how much paint to buy or whatever. Okay. Make sure you write down what decomposing is, and then write down the hint. That means to break it into triangles and rectangles. Okay. If you need to pause, go ahead. I'm going to go on to the first example. Okay, in example number 1, we're going to find the area. Now, if you know what a trapezoid is, this would be a much easier formula for that. That'd be easier, but we're going to do this by breaking it down into triangles and rectangles. So right here, the dotted line already gives me one piece. Okay, so I'm going to draw a line there, and I'm going to draw a line here. Now, I know these two triangles are supposed to be congruent because of my tick marks out there tell me that they are congruent. Okay, so now, what do I know about the sides here and here? I need to know those lengths. Well, if I know this top part is 15, then I know that this bottom part is 15. And 23 minus 15 equals 8, which means I have 8 feet left over. Well, since the two sides are equal, that means this has to be 4 feet, and that has to be 4 feet, because 4 feet, 15 feet, and 4 feet equals 23 feet. Okay? Now I know my triangles. Well, I have 2 triangles right here. The base of the triangle is 4. I just figured that out. And the height of the triangle is 9. So first I'm going to do 1/2 times the base times the height. And that's going to be 1/2 4 times 9. 4 times 9 is 36. Half is 18. So I know that my first triangle is 18. I'm going to write that in there so I remember. Now my second triangle is also going to be 18 because they're the same. So I don't need to redo the work because I know that they're the same. So I'm just going to write 18 for that one. Now this rectangle in the middle now does not have a base of 23. Remember, we broke it down. It's the 15 and the 9. So that has base times height. So that is 15 times 9. And when I multiply 15 times 9, I get 135. So that's 135. So now I found the area of each piece. Now what I'm going to do is put it together in one large shape. So I'm going to add up all those areas. 18 plus 135 plus 18. And when you add up those, you are going to get 171 feet squared. Remember, this is area, so it's feet squared. So that's how you can find the area, by breaking it into its smaller pieces. Okay, if you need to pause, go ahead. Otherwise, I'm going to move on to the next example. In our next example, we have basically a couple of rectangles put together. Now, I could break it this way if I wanted, or I could break it that way if I wanted. Either way is fine. So I don't care which way you want to do it. I'm just going to break it this way here. Okay? Alright, now, when I break it here, I got 7 and 2 for this rectangle. Alright, that's already written. But this rectangle right here is 3, and I need to figure out what this measurement is. Well, if this whole side is 5, and this side is 2, that means that this side has to be 3. Because 3 plus 2 equals that 5. So you have to pay attention to your lengths of your side. You don't want it to overlap them. Now I'm just going to find the area of each. Base times height. I'm going to do this top one first. 7 times 2 is 14, so that has an area of 14 centimeters squared. And I do the bottom one, that's base times height, that is 3 times 3, and that is 9, so that has an area of 9 centimeters squared. So, I put them back together for the full shape, and I get 14 plus 9, and that is 23 centimeters squared. Remember, area is squared centimeters, or squared units, so don't forget to do that. Okay, so 2 rectangles, you break them down, find the area of each, and put them back together. Okay, if you need to pause, go ahead. Otherwise, I'll be moving on to my next example. Alright, my next example, we're going to do this by actually finding the area of a larger object and then subtracting what's missing. So I really have a big triangle right here. Okay, I have a big triangle right there, and then I'm missing that rectangle in the middle. So what I'm going to do is find the area of the big triangle. That's easier than finding each of those shaded parts. Okay, I'm going to find the area of the big rectangle. Now the gray shaded region is what I'm trying to find the area of. So first I find the area of the big triangle, so that's going to be 1/2 base times height, 1/2 times 10 times 15. Okay, there's the base, there's the height. So that's going to be 75 meters squared. So that's the area of the large triangle. So the large triangle is 75 meters squared. Now I'm going to find the area of this rectangle that we're missing. It's actually a square because it's 5 by 5. That's not shaded in. So that's a rectangle, so that's going to be base times height. So that's 5 times 5, which is 25 meters squared. Well, I'm not putting them together to make my shape. I cut out the rectangle. The 25 meters is cut out. So that means I'm going to subtract. So I'm going to do 75 minus the 25 that is not part of the shape. And that leaves me with 50 meters squared. That means that what's left, the shaded area, the gray shaded area, is 50 meters squared. And that's how you can find the area of irregular shapes when you're cutting something out of it. Like that initial picture with the windows, you would find the area of the whole wall and then subtract the area of each window. And that would tell you the remaining area of what is actually wall. Okay, if you need to pause, go ahead. Otherwise, I'm going on to one more example. Okay, I want you guys to try this on your own first, so please pause this, and then when you're done, press play. Okay, hopefully you actually paused this and did this. What I'm going to do is I'm going to find the area of the larger rectangle first. So that's going to be base times height, which is 11 times 8, which is 88. Now, I am missing this part here. This would be like if I was going to do decking for a pool or something. Okay? And I wanted to, I could find the area of the large thing and then subtract the pool. Alright, now I'm going to, now hopefully your pool is bigger than 8 inches by 11 inches, but this is an example. So now I'm going to find the area of that rectangle right there. The inside rectangle, base times height, that is 9 times 6, which is 54. Since that is not shaded, that's taken out, it's cut out of the shaded gray area, I'm going to subtract these. 88 minus 54. Is 34, and then inches squared. Do not forget your units. Okay, 34 inches squared. Now, you could have found this by breaking this object maybe into 4 rectangles. 1, 2, 3, 4. You could have done some math and found, what the size of each one of them is. You do have enough information for that. But that, I think, would be more work than finding the area of the big rectangle, finding the area of the small one, and subtracting it. Okay? That is it. Have a great night, and I will see you guys tomorrow.